Hello everyone. One minute, I will come back. Okay, so we are going to discuss transmission line part 10. In this topic, what we have discussed, VSWR. So today we are going to discuss VSWR again. So today is our VSWR again. Next, so today is our topic VSWR. Then we are going to discuss VSWR. So for short circuit we have discussed, for open circuit we have discussed, for match condition we have discussed. So we have discussed for all condition, I think. So we have discussed for open circuit. So there is for summary. Today is our summary part for VSWR. Today we are going to discuss summary part. First point is how do you know that the VSWR is for which condition? So we have to know only by the maxima and minima at load. If minima at load, then it will be ZL less than Z0 or ZL is equal to 0. If maxima at load, then ZL is greater than Z0 or ZL is equal to ZL is greater than Z0 and ZL is equal to infinity. So we can say that if minima at load, then it will be ZL less than Z0 and ZL equal to Z0, ZL greater than is equal to 0. So voltage minima at load, this is neither minima nor maxima. So if voltage minima at load, then it is, if voltage is starting from here, so it will be ZL is equal to 0. If voltage is starting from non-zero, then ZL less than Z0. If voltage is starting here, then ZL greater than Z0, and it is, if voltage is starting from 2Vf, then ZL is equal to infinity. And if neither maxima nor minima, then ZL is equal to Z0. So what are the condition? This is the condition for voltage. If it is current, then the condition will be opposite. So voltage minima at load, this is the condition for ZL less than Z0. If voltage minima at load but it is 0, then it will be ZL is equal to 0. And if voltage minima, neither minima nor maxima at load, then it will be ZL is equal to Z0. If voltage maxima at load, then ZL greater than Z0. And if voltage maxima at load and it will be maximum, so ZL equal to infinity. So there is 5 condition: ZL less than Z0, ZL less than equal to 0, ZL equal to Z0, ZL greater than Z0, and ZL is equal to infinity. So we can write it down through this point. First point is voltage minima at load, that means V minimum, but it is not at equal to 0, so this condition is known as ZL less than Z0. This condition is known as ZL less than Z0. Okay. Second, voltage minima at load. Second condition is voltage minima at load, but V minimum is equal to 0. That means ZL is equal to 0. That means ZL is equal to 0. Then we have C part. That voltage maxima at load. Voltage maxima at load means we have V max less than 2 Vf. That means it will be ZL less than Z0, ZL greater than Z0, and D part is ZL voltage maxima at load, and Vmax is equal to 2 Vf, then ZL greater than Z, ZL is equal to infinity. Then we have neither maxima nor minima at load. Then that means Vmax is equal to Vmin is equal to Vf. In that case, we can say that ZL is equal to Z0. So there is 5 condition. You have to remember this 5 condition is very important to solve the question. So you can remember this point very easily. So current maxima at load, that means it will be equal to 2 If, then it is ZL is equal to 0. Current maxima at load but less than 2 If, then ZL greater than Z0. Current neither maxima nor minima at load, so ZL is equal to Z0, and current minimum at load but not equal to 0, ZL greater than Z0, and current minimum at load equal to 0, ZL is equal to infinity. That means for current, this graph will be opposite. This one is for short circuit, this one is for ZL less than Z0, this one is ZL is equal to Z0, this one is ZL greater than Z0, and this one is ZL is equal to infinity. So for current it will changed. So I will write it down for current also. So for current, what it will be? If it is current, what it will be? If it is current, what it will be? Then what it will be? We have to describe. Then first thing is we have to describe current. So if current is maximum at load, then ZL is equal to 0. This is current is maxima but not equal to 2If, so ZL is less than Z0. Neither maxima nor maxima at load, then ZL is equal to Z0, and minima at load, so ZL less than Z0, and minima at load and it will be equal to 0, then ZL is equal to infinity. So at load you can decide. So we can say that current maxima at minima at load, current minima at load, but current minimum is not equal to 0, but current minimum is not equal to 0, then it will be ZL greater than Z0. Okay, if current minima at load, and it is equal to 0, then it will be infinite. If current minima at load, then what will happen? So current maxima at load, but Imax is less than 2IF. In that case, what it will be? It will be ZL is equal to ZL less than Z0, and current maxima at load, and ZL is equal to infinite when current is equal to 2IF, and neither maxima nor minima at load, so in that case it will be Imax is equal to IF, is equal to IF, and ZL is equal to Z0. So we have first condition, ZL less than Z0, current minima at load but not equal to 0, ZL less than Z0, current minima at load and current is equal to 0, ZL is equal to infinity, and current maxima at load less than 2IF, ZL greater than ZL less than Z0, and for 2IF, ZL greater than Z0. So you can remember this point very easily. Then we have maxima and minima location. So Imax will be equal to, so Xmax will be equal to, that means maxima location of voltage and maxima location of current. So maxima location, so 2n plus 1 lambda by 4 pi, 2n plus 1 2n pi plus theta gamma into lambda divided by 4 pi. Yes sir. Then we can conclude that what we conclude? Then we can conclude that at this point voltage is maximum, current is minimum, impedance is maximum or minimum. So you can say that impedance is maximum. Why? Because voltage is maximum, current is minimum, so impedance is maximum. At this point electric field maximum, magnetic field minimum. So you can use this formula for electric field and magnetic field also. And for electric field and magnetic field, this question is asked in exam in GATE 2024. So then we have minimum location. Minimum location is 2n plus 1 pi plus theta gamma into lambda divided by 4 pi. Yes sir. This is the point at which V minimum at load, I max at load, and Z max minimum at load, and electric field minimum at load, and magnetic field maximum at load. So this is the point for maxima and minima. Then we have fifth point. Fifth point is we have to conclude about what? We have to conclude that what is the distance between two maxima and minima? What is the distance between maxima and minima? So this is the point you should have to remember. And in previous class we have studied that the maxima and minima location is like this. If it is minima, maxima, minima, maxima. Yes sir. So you can conclude that 0, lambda by 4, lambda by 2, like that you will get 3 lambda by 4. Yes sir, you will get like this. Okay, so I will ask what is the distance between minima and minima. So you can say two successive minima location with distance between them is lambda by 2. Minima and maxima distance lambda by 4. Maxima and minima distance lambda by 4. So you can easily conclude that. This is the point. So minima location, distance between them is lambda by 2. Then we have minima maxima location. So minima maxima location lambda by 4. Maxima minima location lambda by 4. And maxima location lambda by 2. So you have studied in 12th class also. Dark light lambda by 2. Bright light lambda by 2. Dark light lambda by 4. Bright light dark light lambda by 4. So you have studied in 12th class also, but here you have studied in electromagnetic wave. There you have studied in case of light. Light is also electromagnetic wave, so you have studied. So we can start this point. Distance between two maxima, two successive maxima. Distance between two successive maxima. How much it will be? It will be lambda by 2. Then I will ask distance between two successive minima. Distance between two successive minima. It will be lambda by 2. Then we have distance between successive maxima and minima, lambda by 4. Distance between successive maxima and minima. Successive maxima and minima, lambda by 4. Then we have distance between two successive maxima and minima. Distance between successive maxima and minima, it will be lambda by 4. Then we have distance between successive minima and maxima, lambda by 4. Minima and maxima, lambda by 4. You can conclude like this. So distance between two successive maxima, lambda by 2. Distance between two successive minima, lambda by 2. Distance between successive maxima and minima, lambda by 4. Minima and maxima, lambda by 4. So you can conclude like this. Then after we have sixth point. What we have sixth point? Then if ZL is less than Z0, what will happen? If ZL is equal to 0, what will happen? If ZL equal to infinite, what will happen? And if ZL is equal to less than Z0, what will happen? So this is the main point here we are going to discuss. So what we have, first point is ZL less than Z0. ZL less than Z0. In this case, gamma L will be equal to ZL minus Z0 and ZL plus Z0. Yes sir. It will be equal to minus K. Yes sir. That means this condition is known as mismatching. This condition is known as mismatching. When ZL is not equal to Z0, then this condition is known as mismatching. Then I will ask, what is the value of then I will ask, what is the value of magnitude of gamma L? So you will say the magnitude of gamma L will be equal to ZL minus Z0, ZL plus Z0 divided to magnitude. Yes sir. Since it is negative, you have studied in mathematics that mod x is equal to x for x greater than 0 and mod x is equal to minus x for x less than 0. Yes sir. So for x less than 0, mod x is equal to minus x. So this one is less than 0, so it will be minus x. So it will be minus times of ZL minus Z0 divided by ZL plus Z0. By using this concept, the gamma L will be equal to Z0 minus ZL, Z0 plus ZL. Yes sir. Then we have VSWR. VSWR is equal to voltage standing wave ratio 1 plus magnitude of gamma L 1 minus magnitude of gamma L, and this condition is known as 1 plus what? Magnitude of gamma L is Z0 minus ZL, Z0 plus ZL, and second one is 1 minus Z0 minus ZL, Z0 plus ZL. So what you will get? You will get what you will get? You will get that Z0 plus ZL, so it will be 2 Z0, Z0 upon ZL, Z0 upon ZL. Similarly, for electromagnetic wave, you will get like this. For electromagnetic wave, so I will say for electromagnetic wave also, this one is eta I and this one is eta T. There is two medium and this one is boundary. Let us assume x is equal to 0 or z is equal to 0. In this case, if eta I is less than eta T, that means incident medium intrinsic impedance is less than transmitted medium intrinsic impedance. In that case, what will happen? In that case, if eta is less than eta T, then we can assume eta T as a ZL and we can assume eta I as a Z0. So Z0 is less than ZL, so I will consider opposite also. So Z0 is greater than ZL or ZL is less than Z0. In that case, gamma is equal to eta T minus eta I divided by eta T plus eta I. Since eta T is lesser, so our VSWR will be equal to, our ESWR is equal to electric field or magnetic field standing wave ratio is equal to 1 eta I upon eta T, eta I upon eta T. So this is the value of eta. This is the value of eta, VSWR. In terms of VSWR, in terms of eta, you can get VSWR in terms of Z0, you will get. So in terms of Z0, you have got this value. So what is VSWR? VSWR is equal to Z0 upon ZL, or you can go through the 1 by ZL bar. 1 by ZL bar. This is VSWR. This is VSWR. Okay. Then we have 7th point. 7th point is if ZL is greater than Z0. If ZL is greater than Z0, then we have gamma L. Gamma L will be equal to ZL minus Z0, ZL plus Z0. Yes, sir. Then we have this one is plus K. Plus K means it is greater than 0. If it is greater than 0, so magnitude of gamma L is equal to gamma L. That means it will be equal to Z0 minus ZL minus Z0, ZL plus Z0, because positive magnitude for positive value is mod x is equal to x, for x greater than 0, so it will be mod gamma L is equal to gamma L. Then we have VSWR. VSWR is equal to 1 plus magnitude of gamma L, 1 minus magnitude of gamma L. Yes, sir. And this one is known as 1 plus ZL minus Z0 divided by ZL plus Z0. Then we have 1 minus ZL minus Z0 divided by ZL plus Z0. What you will get? You will get ZL by Z0. That means ZL bar. That means ZL bar. Then we have, you can relate this one also with this value, that this one is eta I, this one is eta T, this one is Z is equal to 0 or x is equal to 0. So this one is x is equal to 0. Eta is nothing but it is related as Z0 and eta T is related as ZL. So in this case, eta T is greater than eta I and reflection coefficient is eta T minus eta I divided by eta T plus eta I. Yes, sir. Then you have ESWR, electric field standing wave ratio, or magnetic field standing wave ratio. It will be equal to eta T upon eta I. So this is the value of ESWR in electromagnetic wave. So in electromagnetic wave, you can similarly analyze this value. Similarly analyze this value with this one. Then we have 8th point. 8th point is we have short circuit. Which part? Short circuit. So 8th point is ZL is equal to 0. That means short circuit. Short circuit, in this case gamma L is equal to ZL minus Z0, ZL plus Z0. Yes sir. In this case 0 minus Z0, 0 plus Z0. Yes sir. In this case it will be minus 1, and VSWR will be equal to, VSWR is equal to 1 plus magnitude of gamma L, 1 plus 1 and 1 minus 1, so it will be infinite. It will be infinite. And you can go through this point also. You can go through this point also. What is the point? You can point eta I, yes sir, eta t, yes sir, eta t is 0, that means conductor. In case of conductor, this question is asked in GATE exam. So in case of conductor, eta t is 0, so gamma I is equal to eta t minus eta I divided by eta t plus eta I. Eta t is 0, so it will be 0 minus eta I divided by 0 plus eta I. What will it will be? It will be minus 1. So gamma is equal to minus 1, and ESWR will be equal to, ESWR will be equal to infinite. ESWR will be equal to infinite. Then we have another condition, that means ZL is equal to infinite. That means ZL is equal to infinite. This is for electromagnetic wave, so I am deriving for electromagnetic wave for also here. So ZL is equal to infinite, it is open circuit. Open circuit means here gamma L is equal to ZL minus Z0, ZL plus Z0. Since ZL is infinite, so I will take it in denominator. So in denominator it will be Z0 by ZL. ZL is infinite, so it will be 0. It will be 0. So 1 by 1 is it will be equal to 1. So here VSWR will be equal to, VSWR will be equal to 1 plus 1 minus 1 minus 1. It will be equal to infinite. It will be equal to infinite. Then 10th point. 10th point is if ZL is equal to imaginary X. That means purely inductive. If ZL is purely inductive, what will happen? If ZL is purely inductive, then gamma L will be equal to Jx minus Z0, and Z0 is purely resistive for lossy and distortionless and for lossless and distortionless. So Z0 is purely resistive. So resistive for which part? Lossy and distortionless, lossy and distortionless, or lossless or distortionless, lossless and distortionless. We are studying for lossless and distortionless. So Z0 will be equal to which part? R0. Z0 will be equal to R0. Then we have gamma L. Z0 is equal to R0. So R0, ZL minus Z0, ZL minus Z0. So Jx minus R0 divided by Jx plus R0. Jx plus R0. What you will do? You will take minus R0 plus Jx and R0 plus Jx. Yes. Then what is the magnitude of gamma L? Magnitude of gamma L is equal to under root real square plus imaginary square, real square plus imaginary square. So it will be real square plus imaginary square. It will be cancelled out and the value will be 1. The value will be 1. So our VSWR will be equal to, VSWR will be equal to 1 plus 1, 1 minus 1, it is equal to infinite. Then we have ZL is equal to minus Jx. Minus Jx is purely capacitive. Purely capacitive. Okay? Purely capacitive. That means Z0 is equal to R0, and we have a reflection coefficient minus Jx minus R0, ZL minus Jx plus R0, ZL minus Z0, ZL plus Z0. So minus R0 minus Jx and R0 minus Jx. So magnitude of gamma L will be equal to, magnitude of gamma L will be equal to under root R0 square plus XL. So magnitude will be r naught square plus x square and r naught square plus x square. So magnitude will be equal to 1. So magnitude of gamma L is equal 1. So our VSWR will be equal to infinite. VSWR will be equal to infinite. So this is the question asked in the GATE exam. You can easily give the answer. Then we have next point, that we can conclude this point. We can conclude these points. What are the points? What are the points? Then we have ZL is equal to Z0 also. ZL is equal to Z0, gamma L is equal to ZL minus Z0, ZL plus Z0. It is known as 0. So VSWR will be equal to 1 plus magnitude of gamma L, 1 minus magnitude of gamma L. It will be equal to 1. Okay. Then we can go through the point 12, 13th. 13th point is, we have ZL less than Z0. ZL is equal to 0. ZL is equal to infinite. ZL is equal to minus Jx and ZL is equal to plus Jx. That means short circuit, open circuit, purely capacitive, and this one is purely inductive. This one is purely inductive. So what is the value for this one? So for this one, the magnitude of gamma L, since gamma L is equal to minus 1, so magnitude of gamma L will be equal to 1. Magnitude of gamma L is equal to 1. So all these cases have magnitude of gamma L is equal to 1. If magnitude of gamma L, yeah, magnitude of reflection coefficient is 1, one second, why it is buffering? Okay. So magnitude of gamma L is equal to 1, then we can say that complete mismatching. Magnitude of gamma L is 1 and VSWR is equal to infinite. It is known as complete mismatching. It is known as complete mismatching. Okay. So this is the condition for complete mismatching. Then we have ZL less than Z0. Then we have ZL less than Z0, ZL less than Z0 and ZL greater than Z0. In that case, VSWR will be equal to ZL less than Z0, Z0 by ZL. The greater one will be divided by a smaller one. So greater one will be Z0, a smaller one will be ZL, so Z0 upon ZL. Here greater one is ZL, a smaller one is Z0, so VSWR will be equal to greater one upon Z, a smaller one. So greater one is ZL, a smaller one is Z0. Why? Because VSWR is always greater than 1. So in this case VSWR is greater than 1, in this case VSWR is greater than 1, and this condition is known as, mismatching. This condition is known as mismatching. Then we have one more condition, ZL is equal to Z0. ZL is equal to Z0, gamma L is equal to 0 and VSWR is equal to 1. So VSWR is equal to 1 or reflection coefficient is equal to 0 is complete matching. So this one is complete matching. Always try to remember these all points. The summary points you always have to remember. So this one is complete matching or matching condition or matching. So always try to remember this, all these points. This is very, very important in GATE point of view, from GATE point of view. So complete matching, complete mismatching and mismatching, these are all the condition for which part? All are the condition for matching and mismatching condition. So VSWR is equal to 1, complete matching. VSWR is equal to infinite, complete mismatching. VSWR in between 0 and 1 in mismatching. VSWR in between 0 and 1, it will be mismatching. Okay. So we are going to discuss all these points. So it is complete matching, complete mismatching, and then after matching. So these are all points you have to remember. In next class, in Monday class, we will discuss the questions regarding these points, all these points. So 14th question, 14th part. 14th part is it is very important. That means the reflection coefficient value is -1. The reflection coefficient value is +1. So range of reflection coefficient is how much? So they will ask in the GATE exam also, range of reflection coefficient. The range of reflection coefficient is how much? It is -1 to +1. -1 to +1. So it is -1 to +1. The capital bracket is closed bracket. This one is closed bracket. So -1 to +1, or you can write it down like this, -1 to +1. Then after they will ask in the GATE exam a range of VSWR. A range of VSWR. What is the range of VSWR? VSWR range is our VSWR is equal to, I will denote VSWR with rho for further analysis. So rho is equal to 1 to infinity. 1 to infinity. Infinite cannot be closed, so it will be open bracket. So VSWR is infinite. VSWR is 1, and in this case VSWR is greater than 1. In this case VSWR is greater than 1. So we have VSWR, that means it will be 1 to infinity. Then this is the most important point you have to remember. There is the derivation, but the derivation is from Smith chart, but right now we cannot derive from it from here. So I will tell only the points. What are the points? That means VSWR is equal to maximum upon Z0, maximum upon Z0, and VSWR is equal to minimum upon Z0, minimum upon Z0, Z0 upon minimum. Why? Because minimum will be less than Z0, maximum will be greater than Z0. So maximum impedance will be Z0 upon Z0, Z maximum upon Z0, and Z0 upon Z minimum. This is the formula. You should have to remember this. It is very important, and from this point they have asked the question in GATE exam, and I have taught this one in the previous year also. Previous years means I have been taught in from 2014. From 2014 I have been teaching this point, because this point is asked in ECE also. So in ECE we can solve the question like this. So VSWR formula will be like this only. So what are the VSWR formula? You have to remember. What are the VSWR formula? You have to remember. You can ask me, you can get it. 17. VSWR formula is, first one, you have to remember 1 plus mod gamma L. Yes sir. For lossless transmission line. Second one is Z0 upon Z min. Second one is, what you have to remember, ZL upon Z0. Third one is Z0 upon ZL. Fourth one is Z max upon Z min. And fifth one is Z max upon Z min. And fifth one is Z min upon Z max. Sixth one is Z0 upon Z, sorry. Then we have Z0 upon Z min. Sixth one is V max upon V min. V max upon V min. And seventh one is I max upon I min. Or eighth one is E max upon E min. In case of ESWR, it will be E max upon E min. And in case of magnetic field, H max upon H min. So you are writing this SWR, you can write SWR, and this one also. So this one is SWR for transmission line, this one is SWR for electromagnetic wave, H max upon H min, or eta t upon eta I, or eta I upon eta t, or eta max upon eta I, or eta mean upon eta I, eta I upon eta mean. You can remember all this formula, or 1 plus mod gamma and 1 minus mod gamma. You can use this formula, but you have to remember that point, some points, what that this formula is valid for, this formula is valid for ZL greater than Z0, and this formula is valid for Z0 less than Z0. Similarly, this formula is valid for eta t greater than eta I, and this formula is valid for eta t less than eta I. In electromagnetic wave, you will understand what is eta t, what is eta I, and what is eta max, like that thing. But you can remember this formula for this one also. So these are the all points you should have to remember. 16th, 17th, these are the all points. Then we have what? Then we are going to draw a box. We are going to draw a box, which is very, very important. Let us think how many things it can accommodate. As much as of thing we can accommodate in this box. Okay. So first one is condition ZL less than Z0, ZL greater than Z0. They will ask anything from this condition. So ZL less than Z0, ZL greater than Z0. Then at load, what it will be? Vmax value will be, Vmin value will be, reflection coefficient value will be, reflection coefficient will be, and then after VSWR, then after VSWR, and then after Zmax and Zmin, then after Zmax and Zmin. So we are going to discuss so many things. ZL less than Z0. This is the, we are going to write condition. So first condition is ZL less than, ZL is equal to 0. ZL is equal to 0. First condition is ZL is equal to 0. What is the value of Vmax? What is the value of Vmin? What is the location of Xmax? And what is the location of Xmin? What is the value of VSWR? And what is Zmax? These all things you have to remember. What is Zmax? And last one is what is Zmin? What is Zmin? You have to remember Zmin also. Yes. Then, so our Vmax will be 2Vf, our Vmin will be 0, our location of Xmax will be, so ZL is equal to 0, that means minima at load. ZL is equal to 0, that means minima at load. At load means n lambda by 2, and maxima will be at odd multiple of lambda by 2. You can think like this: ZL less than Z0 is minima at load, that means at load X minimum and X maxima. Yes sir. You can accommodate one more thing also. Sorry for that. I have to accommodate so many things. I told you that we have to accommodate so many points here. so that you don't have to remember that much points. This box is enough for you. This box is enough for you. First point is what is Vf. Second point is what is V minimum, V max, what is V min. Then location of maxima, where maxima is located. First of all, yeah, where maxima at load. At load what will happen? So at load, maxima or minima. Yes, sir. Second thing is you have to remember the location of x max. What is x max? What is x max? X max. Then you have what is x min. What is x min. Then you have what is VSWR. What is VSWR. Then you have what is Z max, means maximum impedance and minimum impedance. These all things you have to remember. These are the all points they have to ask. So voltage maxima is 2 Vf, minima is 0. At load, minima at load, minima at load, and x minimum is at load, so L lambda by 2. X maximum is at load, x minimum is at load, so at lambda by 4 maximum. VSWR is infinity, and Z max is Z max is what is Z max? So Z max is equal to Z naught square upon ZL. That means infinite. So Z max is equal to rho into Z naught. What is Z max? Rho into Z naught. Z max is equal to rho into Z naught. How it is rho into Z naught? You can go through the SWR is equal to Z max upon Z min. So Z max is equal to VSWR into Z naught. Z min is equal to Z naught upon VSWR. So Z max is equal to rho into Z naught. Z min is equal to Z naught upon rho. So you can go through this point also. This one is rho and this one is rho. So you can analyze this also like this. Z max is equal to rho into Z naught, and Z min is equal to Z naught upon rho. Z naught upon rho. Yes, you can analyze from here. Yes, sir. So what is the value of rho here? The value of rho is infinite. The value of rho is infinite. So it will be infinite. And Z min is Z naught upon rho. Z min is equal to Z naught upon rho. So what is Z naught upon rho? So Z naught upon infinite is 0. So it is 0. Because rho is infinite. Then we have ZL less than Z naught. ZL less than Z naught, then Vmax will be less than 2 Vf and Vmin is greater than 0. And less than Z naught, so minima at load. But Vmin is not equal to 0. Then minima at load, that means at load x minimum, and at lambda by 4 it will be maximum. VSWR will be ZL less than Z naught, it should be greater than 0, so Z naught upon ZL. And what is the value of Z max? So rho into Z naught, it will be rho into Z naught. And what is the value of V min? Z naught upon rho. So you know the value of rho. You know the value of rho. What is the value of rho? Rho is Z naught ZL. So Z naught upon ZL into Z naught. Z naught square upon ZL. And Z naught upon ZL divide Z naught upon ZL divide Z naught. So it will be ZL. How I am calculating? I will tell you. It is Z max is equal to rho into Z naught. Rho into Z naught. Rho is how much? Z naught upon ZL. and into Z0. So it will be Z0 square upon ZL. And Zmin, how we are calculating? Zmin is equal to Z0 upon rho. So it will be Z0. Rho is Z0 upon ZL. So it will be ZL. Like that I am calculating this. Okay. Like that I am calculating the maximum value and the minimum value. Yes, sir. Then after we have ZL is equal to Z0. ZL is equal to Z0. What will happen in case of ZL is equal to Z0? So ZL is equal to Z0. There is no maxima and no minima. So neither maxima nor minima. Neither maxima nor minima. That means neither maxima nor minima. That means X max nothing. X means nothing. VSWR 1. Z max Z0 and Z min also Z0. Why? 1 into Z0 1. Z0 upon 1 1 Z0. So 1 into Z0 Z0. Z0 upon 1 Z0. Then we have what we have? ZL greater than Z0. ZL greater than Z0. ZL greater than Z0. So our Vmax will be less than 2 Vf and Vmin is greater than 0. And here maxima at load. Which maxima? Voltage maxima I am saying. So voltage maxima at load. At load maxima, so n lambda by 2. And at lambda by 4 minima. At lambda by 4 the minima will be there. VSWR is ZL is greater than Z0. VSWR should be greater than 1. So ZL upon Z0. ZL upon Z0 into Z0. ZL upon Z0 into Z0. ZL. ZL upon Z0. So Z0 upon ZL upon Z0. It will be Z0 square upon ZL. Just put the value of rho here. This rho value, put it here. This rho value, put it here. You will get the maximum minimum value of impedance. ZL greater than ZL is equal to infinite. So Vmax will be 2 Vf. Vmin will be 0. And the maxima at load. Maxima at load. And at load is maxima. So L lambda by 2. And minima will be at lambda by 4. And the VSWR will be infinite. Infinite into Z0, infinite. Z0 upon infinite, 0. So minimum impedance is 0. Maximum impedance is infinite. So you can give the everything, the answer you can give. Every answer you can give. So I will ask ZL is equal to Z0. What is the maximum value of voltage? 2 Vf. ZL is equal to Z0. ZL is equal to 0. What is the minimum value of voltage? 0. What is the location of maxima? So maxima, minima at load. Voltage minima at load. What is the where voltage minima? So voltage minima at load. Voltage maximum is at a distance lambda by 4 from the load, because voltage maximum will occur because minima is at a load. So voltage maxima is at lambda by 4 distance. How it is? So you can think it here. If minimum at load, then maximum is at lambda by 4. If maxima at load, then minimum is at lambda by 4. So minima maxima difference is always lambda by 4. So at load it is minima, so at lambda by 4 maxima. At load it is minima, at lambda by 4 maxima. Voltage minimum will give Z minimum. Voltage maximum will give Z maximum. What is the maximum value of impedance? Infinite. What is the minimum value of impedance? 0. Where minimum impedance occur? At load, at lambda by 2, at the lambda, at 2 lambda and 3 lambda by 2, everywhere. And where maximum impedance will occur? At lambda by 4, 3 lambda by 4, 5 lambda by 4, 7 lambda by 4. Like this you have to remember this point. Next point is ZL less than Z0. Vmax is 2 Vf, less than 2 Vf, greater than 0. So minima, voltage minima at load. At after lambda by 4 distance there is voltage maxima, because at load minima, so at lambda by 4 distance maxima. So at load minima, at lambda by 4 distance maxima. At load Z minimum, at lambda by 4 Z maximum. at load ZL, Z minimum, at lambda by 4 Z naught square upon ZL. So voltage minimum is at load, so impedance minimum is at load. Impedance maximum is, voltage maximum is at lambda by 4, so impedance maximum is at lambda by 4, and at lambda by 4 impedance formula is Z naught square upon ZL. So you can remember also like this. ZL is equal to Z naught, neither maxima nor minima, no location of maximum, voltage maxima, minima, and VSWR is 1, Z naught, Z naught, because neither maxima nor minima, so neither maxima nor minima impedance also. ZL greater than Z naught, so maxima at load, so lambda by 4 distance minima, so maxima at load, lambda by 4 distance minima, and the VSWR formula is like this, and you can assume like this, you can put the formula VSWR, you will get the value. So this is the box you have to remember. This is the box you have to remember. So location of voltage maximum and minima are same. Voltage minimum and impedance minimum are same. You always have to remember. Voltage minimum and impedance minimum location is same. At voltage minimum, current is maximum. At voltage maximum, current is minimum. You have to remember these all points. What you have to remember? Voltage minimum, current maximum, and impedance minimum. Yes, and voltage maxima, that means impedance maxima, and current minimum. You have to remember this point. So voltage minimum, X minimum and Z minimum are same, and something like this also, V max, X max and Z max are same. Okay, V max, X max and Z max are same. So like this you can write it down the board or this table. This is most important table here. This is the most important table here. Then we have what we have. Then we have next thing. What are the things next? 17, 18. 18th part. What we have? Location of maximum minima, location of minimum voltage, location of current maximum minima. We have find out. Then we have what we have. So in GATE exam, the reflection coefficient is given. Then you can calculate VSWR. If VSWR is given, then how you will calculate the reflection coefficient? If VSWR is equal to rho, so it will be 1 plus mod gamma L, 1 minus mod gamma L. Yes sir. So mod gamma L will be equal to how much? Rho minus 1 divided by rho plus 1. So this is the formula for mod gamma L in terms of VSWR. This is the formula for mod gamma L in terms of VSWR. So it is very, very important. It is very, very important. This is the point here. 19th point. 19th point. What they have given? They have given VSWR. They have given voltage maxima and minima. And they are asking what is the value of ZL? What is the value of reflection coefficient? This type of things they are asking. So how will you solve this? So VSWR is equal to finite. Yes. There is another condition, infinite also. So first of all I will deal with finite condition. Then in exam it is given voltage maxima at load. Voltage maxima at load. So voltage maxima at load, that means you have to go to the table. Voltage maxima at load. Voltage maxima at load. So at load voltage maxima. And the condition is ZL greater than Z0, and the VSWR is ZL upon Z0. Yes sir. So maximum at load, so voltage maxima at load, that means ZL greater than Z0, and ZL greater than Z0, that means VSWR is equal to rho is equal to ZL upon Z0. So they will ask what is the value of ZL. They will ask what is the value of ZL. So you can give the value of ZL also. So ZL will be equal to rho into Z naught, and they will ask also what? Reflection coefficient. The reflection coefficient is equal to ZL minus Z naught, ZL plus Z naught, ZL minus Z naught, ZL plus Z naught. You can remember like this. They may be give the value of voltage minima at load. They may be give voltage minima at load. Yes sir. They may be give voltage minima at load. So what you will do? If voltage minima at load, then what will happen? At load there is voltage minimum. So in that case, ZL is greater than ZL is less than Z naught. In that case, VSWR should be greater than 1. So Z naught upon ZL. In that case, what will be the value of? In that case, what will be the value of ZL? So ZL is equal to Z naught upon rho. And in that case, gamma L will be equal to ZL minus Z naught, ZL plus Z naught. So this is the way you can calculate the formula of gamma L, ZL and everything. In this way, they will ask the question. Then there is a chance that VSWR is infinite. So if VSWR is infinite, this one and this one. VSWR is infinite, that means short circuit. VSWR is infinite, that means open circuit. Okay. And voltage maxima at load, so at short circuit, minima at load, and at open circuit, maxima at load. So like that things. Okay. This thing they will ask. At this, they will give something like this also. Voltage maxima, yes sir. They will give current minimum also. They will give current minimum. They will give impedance maximum. All are same thing. Voltage minimum, that means current maximum. That means impedance minimum. So if anything, they will say the same thing. Impedance maximum, voltage maximum. Current minimum, voltage maximum. Impedance minimum, voltage minimum. Current maximum, impedance minimum, voltage minimum. Like that you can remember. Then we have 20th point. What is the 20th point? If VSWR is infinite. If VSWR is infinite. So there are 4 conditions. One is ZL is equal to 0. Second is ZL is equal to infinite. Third one is ZL is equal to minus Jx. And fourth one is ZL is equal to plus Jx. But this is complex, so we will study later. This is complex, we will study later. We will study tomorrow class and we will do the questions. Okay, so this one is the complex load. So we will study tomorrow class, only 10 to 20 minutes point, 10 minutes point. Then VSWR is equal to infinite. Then there is 2 part, Vmax at load. Vmax or current minimum or impedance maximum at load. That means we have ZL is equal to infinite. That means we have a reflection coefficient is equal to 1. Yes sir. Then they will give Vmin at load, means minima at load. Imax, yes sir. Zmin, yes sir, at load. Then what will happen? ZL is equal to 0. Then we have gamma L is equal to minus 1. There is a chance that neither maxima nor minima at load. Then what will happen? Then that will be the complex load. So we will study tomorrow. So what we have taught you? We have taught you the points that for real load only. Minima at load, minima at load, neither minima nor maxima at load, maxima at load and maxima at load. Like this all things are you have studied. Then you have studied current minima, something like this, current maxima, current minima, neither maxima nor minima. You have studied like this. Yes sir. Then this is the maximum minima location. This is the most important point we will study in tomorrow class. And we have, this is the derivation of ZL less than Z0 or Z0 upon ZL, how we are getting. Then we have studied when short circuit, when open circuit, what is ZL, VSWR, when inductive and purely inductive, purely capacitive, what is VSWR. Then complete mismatching, complete matching we have studied. Then we have maximum minima impedance we have studied. Then we have studied this, all this point. Then this is the most important point. Then these are the most important points. So we have studied in summary most important point. 3-4 points are remaining. That means maximum location should lie where, minimum location should lie where, and if neither maxima nor minima at load, then complex load will be there. Then what will happen? These all things we will study in the Monday class, and after that we will do some questions, 10 to 15 problems in Monday class. So our VSWR will be over, and you can do the problem of PYQs. So you can solve PYQs very easily. Okay. So today is our, so for today class is only this much. What we have studied today, summary of VSWR, and if you are if you can download Unity app, and in Unity app it is very beneficiary, and you can join my channel, Telegram channel Sonu Sir PW. It will be very helpful for you. If you are to any doubt, any question, you can ask me. Thank you everyone. We will meet in the next class, Monday class. Thank you.